Hi everyone, today I want to talk about units and systems of measurement and why they are important to consider when studying physics. So physics at its core is an experimental discipline. It's focused on performing experiments, measuring and observing the physical world, and coming up with conclusions based on those measurements. So you hear a lot about, when you think of physics, you think of difficult math and maybe like black holes and quantum mechanics and all these fun things, which are valid parts of physics and are definitely legitimate. But at its core, if you don't have measurements to validate these things, if you don't have an experimental process or an experiment to validate these, then they're really meaningless, because physics sets out to describe a model of the physical world. And so measurement is a very core part of physics. But in order to measure something, you need to have a definition of what it is that you're measuring. And this is where units come in. So I'll give you an example in one sentence about why units are so important. Consider this. A car travels 100 in 1. What does this mean? Nobody knows, right? It's meaningless. What is 100? What is 1, It doesn't mean anything physically to us. But if I add this, then it means something to us now. A car travels 100 kilometers in 1 hour. This is something that we can intuitively understand. And so that's what a unit is. It's a suffix we add onto a number to define it for what it is. And these units can be different around the world. For example, the United States uses what's called the imperial system, which would measure length in miles or feet or something like that. But most commonly around the world, and the most accepted in the scientific community, is the SI system, which is also known as, more commonly perhaps, the metric system. And this system would measure length in meters and kilometers, like I have up in the sentence at the top. Now, the SI system is composed of 7 base units. We call these base units, which are units that you can derive every other unit from. So every unit in the system, in the SI system, can be derived from these units. And I'll write them all down. There's only 7 of them. One of them is time, which is measured in seconds in this system, and all systems actually. Length is in meters. Mass is another one, which is in kilograms. Then you also have temperature, which, if you're in a country that goes by the metric system, you would think it's in Celsius, but it's actually, in science, what we use is Kelvin, which I will talk about in detail in future videos, but for now, it's measured in Kelvin. Then we have electric current, which is measured in a unit called amperes, which is named after a guy named Ampere, and it's given by capital A. Then maybe a more abstract one, amount of substance. And if you've taken high school chemistry, you'll definitely be familiar with this one. It's measured with the unit of mole. Finally, one more, luminous intensity, which is measured in candela. So these 7 units are the basis of the metric system, and from these units, like I mentioned, you can derive every other unit. And I'll give you a simple example of this. Probably the simplest example that you can find is velocity. Now, velocity is defined as the distance that something travels in a certain amount of time. And so the formula would be the length over the time. But if you look at the base units that I've listed, you've got a length and a time here. And those are given in units of meters and seconds. And convention has these square brackets around the units. But you can see we now have a new defined quantity, velocity, which is a combination of two base units. And that means, that's an example of a metric system unit that's a combination of two base units. And obviously it could be more than two. It could be any combination of multiplication or division of these 7 units. And so that's just a basic introduction to units and the SI system. And it is important to become familiar with this and at least know of its existence and know the importance of units. If you don't understand what these units are yet, that's fine. Just knowing that base units exist and how important units are for studying physics is important, and we will definitely get to what these units are in the future, and as we solve problems you will become very familiar with units as you will see them in every single problem, probably without exception. So definitely become familiar with that, and I will talk more about it in future videos, but I hope this was a helpful high-level introduction to it, and I will see you next time.